we are required to enter various information concerning the assessment and design of the project if available, including design consideration parameters, different technologies employed, sources of the input sludge, any local project constraints, and the types of final output. If known, enter the design input flow rate of sludge, which is the quantity of fecal sludge expressed in cubic meters the treatment plant is designed to receive per day. The parameter describes the design treatment capacity of the treatment plant itself. Next, we are requested to enter the design input fecal sludge characteristic for chemical oxygen demand (COD), expressed in milligrams per liter. It is important to design effective treatment processes in order to comply with regulatory standards for effluent discharge. The design input fecal sludge characteristic for total solids (TS) is a measure of the total amount of organic and inorganic solids within the fecal sludge and is another parameter that can be critical for process design and is a performance parameter expressed in milligrams per liter. Next, we enter the population the treatment plant is designed to serve. If not exactly known, it can be estimated following the methodology provided by clicking the green information icon within the text input box. Next, we enter the space required by the treatment plant site in relation to the design input flow, expressed in square meters per cubic meter of the treatment capacity. The methodology is provided by clicking the green information icon within the text input box. Then, we are required to mention all of the treatment technologies employed in the treatment process of the plant by ticking all the boxes of technologies that apply. This is important to categorize and compare treatment plants and evaluate their efficiency on the platform. In the case of this waste stabilization pond case study, we will be selecting the technologies that apply. Next, we need to define the sources of the fecal sludge incoming to the treatment plant. This indicator is important to estimate the sludge's characteristics, as they vary depending on the origin of the sludge. The design of the plant should be based on the sludge characteristics. For example, the sludge from hospitals is likely to be more hazardous and will need special treatment. It is possible to select several answers here. Any local constraints that are faced in the area where the treatment plant is located must be defined, and so, we tick all boxes that apply in this next section. This is useful to know to get an idea of the local context, and may provide reasoning for any of the challenges faced by the concerned community and the wash sector operating in the region. Select the design life of the treatment plant if known. This denotes if the treatment plant is employed as a short-term or long-term solution. Next, we are required to specify the final outputs from the treatment plant by ticking the relevant boxes. The final output from the plant can be a variety of constituents including sludge, effluent, biogas, and compost to name but a few. Knowing the different plant outputs facilitates the design and implementation of specific disposal or end-use systems accordingly. Then, we are asked to specify the skill level required to design, construct, operate, and maintain the treatment plant by ticking boxes for all involved personnel. This is a useful indicator to gain an understanding of what type of skills are required to have a successfully functioning treatment plant, to employ suitable personnel for various tasks, and to select technologies to match the available local skill level. Finally, we are required to enter assessment and design information regarding the treatment plant. Information entered here should provide a brief overview of the feasibility of the treatment plant with regards to assessment of the existing setting and the resources available, and the design in accordance with the local context circumstances. Some important information to include in this section would be the characteristics of the raw sludge, the landscape surrounding the plant, types of toilets and containment pits, the average number of users per pit, proximity to water sources, and information concerning the soil and climate. Other case studies may offer good examples of how to prepare the description of the assessment and design.